Hey guys, so this is the second video in our writing Solana programs in assembly series. So in this video, we're going to be doing account verification with assembly. So typically when you're writing Solana programs, you need to do checks on the accounts you're going to be using in that program. And what we're simply going to do is just do those checks in assembly. So let's get started. Go Steve. So remember, we're using the sBPF toolchain. So to start up a new project, we just need to do sBPF init and the name of our program. So we're calling it checking account. No. Okay, and finish checking account. So finish checking account. Sorry. Okay, so I realized in my last video I really didn't give a rundown on what these like the templates that the sBPF toolchain gives us when we're doing it. So deploy is where our binary and key pair are going to live. Source is where we're going to have our test and we're going to have our assembly. So our assembly file is inside a folder that has the same name as the name we give to our project. Then we have git ignore, cargo.storm, pretty basic stuff. So in this video, we're going to be like, as I said earlier, we're going to be like doing running checks on a couple of accounts. So this program that we're writing is actually from the program examples repo. We already have something like that in native in Pinocchio. So what this does is just, okay, it does some verification on 4 particular accounts. Yeah, so this account here, these 4 accounts. So let's copy that for a minute. And in our README, let's try to like highlight the goals of our program or the program we're trying to write. So, okay, first of all, let's like put out the accounts we're going to be using. So we have a payer account, accounts to create, account to change, and system program. So these are the accounts we're going to be verifying. And the checks we want to place on these accounts are going to be, first of all, we want to check if the number of accounts that pass. So we want to make sure that the number of accounts is 4 because there are 4 accounts here. Next, we want to make sure payer is a signer. We want to check that accounts to create has not been created. We want to check that account to change has been created, and we want to check that the system program account passed, that the ID is the same as the ID of the system program. So system program ID is correct. That's it. So in the previous video, I talked about R1 having the input buffer, and that just points to all our accounts, the instruction data, and all that. So it has that layout already. So in the instance where, okay, we pass an instruction and we have all these accounts, it's going to be in the offset of R1. So it's just going to be in the offset of R1. And typically we'd have to calculate that ourselves, but thanks to the guys at Blue Shift, we can just like use their tool to calculate that ourselves. So this is the it's just the UI, a website they have built. So you just come to add accounts. So our first account is payer. After you put the name of the account, you have to like check the type of account it is. If it's a CISVA, if it's a mint, it's a token. In this instance, it's just a regular account, so we just say it's a typed account. If it had like data we're supposed to put, would add fields and all that, but in this scenario we don't. So next is going to be account to create, and this also should be a typed account. Add account to change, make this a typed account, and finally the system program. Yeah, this is our system, so that's fine. And yeah, this is just like the layout of how the accounts and instruction data are in the input buffer. So let's clear this out. So what we're doing basically is just saving them as const so that we don't need to calculate all these things ourselves. So me, I typically like to just put like some form of padding around them so that, okay, mentally I can still see the number of accounts I have. So let's put our checks over here so that we can be on track with what we're doing. So as usual, it's just dot global without the a entry points. Let me do that yet. Entry points, then go. So the first check is to check if payer the number of accounts is 4. So to do that, we just need to do load double word for memory R6. So we do R1 plus num of accounts. Then we do jump if not equals to R6 for then a label. So we're going to call this label invalid number invalid num accounts to make it short. Let's just put the exit in here. So so we need to define this label. So we're using labels as like errors in this instance. So load double word R01 and exits. Okay. So what we're doing here basically is that, okay, first look at remember that R1 contains the input buffer, and all we got here are just like offsets of like particular pieces of data of where they are in the input buffer. And so it's just like, okay, you have R1, the starting point, and you just add it with the constants that the offset is supposed to target to. And that gives us this num account. So the number of accounts are here. So just imagine it's okay. Think about it without the braces, the brackets. It gives us the offset of where the number of accounts is, and the braces just help us like dereference that and give us the actual value. And once that's done, the actual value is stored in R6 over here. So this instruction loads this piece of data from memory and stores it in R6. Then over here, we use another instruction called jump not if not equals to. So what this is checking is that the contents of R6 is not 4, it jumps to this spot. So, and also you remember in the previous video, I said R0 contains the return case. So if it's 0, that's a success case. And if it's anything but 0, that's an error case. So notice we're setting it at 1. So we're saying that, oh, it's an error. And it's like error 1 code. So this is just like a handy way of setting up errors. So once we set it to 1, we set it to X, and that means that this program failed. So what we're basically doing here is that if the number of accounts is not 4, then just fail and return the error code 1. So what I'm going to be doing is that once I write like a error or a check, we're going to try to eat that error in with the tests. So give me a minute. So the example I wrote in the program example uses light SVM. So we're also going to be using light SVM here just to keep things straight. So a couple of the examples not even a couple, all the examples that I have all the examples I'm going to be like working with in this series are actually from the program examples repos from the Solana developers organization. So I want to keep that thing check, like, so you could always go there to reference what we're doing here. But yeah, we're just doing the the typical setup. And now I realize I've now built this program, our assembly, to see if it actually works. So remember, to build is just sBPF build. And since it builds, it means, oh, we've not done something terrible yet. So checking accounts, so okay, then this should work. And svm.add program and unwrap. So when I'm writing like SVM programs, I just like to skip to the end, just send a transaction so that I can know what I'm supposed to build, because I'm sorry guys, I don't remember every single type I'm supposed to use. So first transaction, transaction, new signed with pub key. Okay. To get blockage, it just says VM blockage, latest blockage. Got that. Signing keys. Okay. Yes, signing keys. Okay, that reminds me of the keys we need. So remember the accounts for passing. We need the payer, keeper, new. Let's accounts to change. Not create first. False keeper. New. Sometimes I don't think I've transferred all of my VS Code shortcuts here, which is crazy. I still remember my VS Code shortcuts even though I've not used them in years. Signing keys. So over here, it's going to be accounts to create because we're creating an account. And then payer, that would be some, and it's payer.key. This should be a reference. Yeah. It is a reference instruction. Let's say. Let me see the type of instruction. Okay, it's just an array of instruction. So time to write the instruction. Let's instruction equals instruction. Exactly. Thank you. So for program ID, we already have program ID here. For data, let's just set an empty vec since we're not sending anything in particular. Then for account, is account a vec? Yeah, account is a vec. So vec, account meta, new. So first we have payer.pub key, and payer is going to be a signer, so true. Why did it do that? No, I saved so it limited it. I need to go add my shortcuts. Okay. So first account payer, second account to be accounts to create. Since we're creating this account, it's also going to be true. It's a signer. Account to change. This is going to be false. And we also have the system program. So I think that would be Solana system program ID. And yeah, we should be good to go. Instruction. Yeah. So we sent our program. What to do next? Okay. I want to do some login so that the result we get looks better for field cases, because with assembly the field cases looks pretty weird, and I want it to look easy for you guys to understand what is going on. Yeah, we should go. Okay, so sBPF build, that works. So sBPF test. Yeah, and now we have an error. Why do we have an error? Not enough signers. Not enough signers. Why is that? Not enough signers shouldn't even be what? Not enough signers. We do have enough signers. Payout, true. Oh yeah, I didn't set this to false. And also I didn't do airdrop on our payer account. So since it's the one paying, we need to do some airdrop there. So it's going to be payer.pub key. Then Lamport times 10. Well, I'm going to comment this out to show you guys the correlation with the error and why setting this to false made it work. So that error is going to change and it's going to give us an error about accounts not found. Yeah, accounts not found. So that's because of payer. There's no Lamport inside payer, so the account doesn't exist. That's why it's telling us that. So with this, now everything should work. Why is it not working? Okay, I didn't make this a reference. and just unwrap. And yes, our program works. And let's change this to logs because this is annoying to look at. And look, our program works. So remember I said we're going to try to make our our cases fail, like trigger the error intentionally. So right now let's remove one of the accounts. So now the program is going to be receiving like 3 accounts, and that should fail. And yeah, it fails, and it also giving us the same error we got, the custom error 1. Now we got 1 over here. So that's right. Let's fix that and add another. So yeah, also to make things faster, let's do build and test. Build and test, because we're going to be adding build and test. Okay. So the next case we're adding is to make sure payer is a signer. So easy way to know if payer is a signer is just to look at the header and check for the it's the signer boolean, which is going to be 0 or 1. So how we do that is that we're going to look into payer header, and we're going to increment by 1 byte to get a signer. And if it's 0, then it's false. If it's 1, it's true. So just like we did before, we're going to load. Okay, we can't do load double word because it's a single byte. So R6 R1 plus payer header plus 1. So if we did just payer header, would get is dupe. So we don't want is dupe, we want what's next, which is signer, and that's how we're adding it by 1. So just like we did before, jump if not equals to, so it's going to be R6 1, and you get another error which is not signer. So this is just a label that we're using for error cases. So just come here, and just so we can keep track of things, let's just make this 2. So we're saying, yeah, we're saying, okay, it should be equals to 1 because of we expect that if it's 1, that means payer is a signer, and if it's not 1, then jump to this error. So let's run it, and right now everything should be working fine if I did everything right. So see, it's working fine. So now let's try and make payer not a signer. So to do that, we need to create like a whole fake payer. So over here, just paste this. Then let's do fake payer. Fake payer, fake payer. Then over here, we just do fake payer. And if we run this, it should fail with custom error 2. It doesn't fail with custom error 2. Why? Not enough signer. Okay, I also need to make this false. And yeah, it fails with custom error 2. So what this is just telling us is that, okay, payer over here is not the signer. So that verifies that, oh, our check is working. So let's set that back, set this to be true, remove the fake payer over here. What else? Let's run it to see if it works. Yeah, it works. So let's go to our next case. So to make sure that accounts to create has not been created. So an easy way to know if an account is created or not is to check the lamport it has. So yeah, we're just going to verify if accounts to create has any lamports in it. So if it does have lamports in it, that means it has been created, and that is wrong, and it should throw an error. So let's just load from memory to R6. Also, every time we're doing we're loading into R6, we're like rewriting it. So the value that was here is being rewritten here, it's being rewritten here, and it's pretty harmless in this case. So we do R1 plus accounts to create lamports. So it's precisely where the lamport is. That's why we don't need to add any more like I don't know, offset. It's at the right target. So jump if not equals to 0. and yeah, error. Um, let's just say um, account exists. We probably want it to exist. So if the account exists, that is the error case. Let's make it 3 and exit. So if we run our code now, it should pass because of, okay, account to create does have no lamp ports, unless I did something wrong. Okay, I didn't do anything wrong. So now let's try to like add lamp ports to accounts to create, and let's see that error be triggered. So over here we just do accounts to create. So easy way to just create an account is just to add lamp ports to it. So account to create, it's below. So account to create, just put this over here and let's run it. If we run it, it should fail. Now yeah, it fails with custom error 3. And remember, for each case, we're giving it a unique error so that we can keep track. So custom error 3. And so now we just need to comment this out and run this again. And it works. So on to our next check. What is our next check? Our next check is account to change has been created. So for this one, we just need to check that, oh, it does have lamp ports in it. That means, okay, the lamp ports in it are not 0. So just like we did before, we can legit just copy this whole thing here. And we just change this to accounts to change. Yeah, accounts to change. And yeah, we do something different. Yeah, we say jump if equals to. Since we previously we were saying jump if not equals to, now we're saying jump if equals to. So now we're saying that it should jump if R6 is equal to 0. So that's basically telling it that, okay, if this account does not exist, jump to this error case. So account error account does not exist. This is a terrible error, but forget about that now. Yeah. So right now, since remember, right now in our test, we've not written any code to actually create account to change. So right now, if we do run this should fail. Yeah, it fails with custom error 4. So that means, oh, we did it right. And to actually create the account, all we need to do is just drop lamp ports to it. So accounts to change, and it works fine. So what's our next error? System program ID is correct. So typically the check we usually do for system programs, be it the token program, the system program, like other programs like that, is just to check that, oh, the program ID is correct. And how we're going to do that here is a bit interesting. So first of all, as usual, we're going to load the system program key to R6, but we're going to do something pretty interesting because of a limit. So as we do this right now, I'm not sure I talked about it in my previous video, but registers are 64 bits in nature, so that's like 8 bytes. And Solana program IDs are about 32 bytes. So this is supposed to be about 32 bytes, but the size is 8 bytes. So it's only going to store the first 8 bytes in here. It's only going to store the first 8 bytes in there. So we need to do verification for like 4 different times because of its limit is 8 bytes. So we need to check the first 8 bytes, check the second 8 bytes, check the third 8 bytes, and check the fourth 8 bytes. So just offsets by 0. Like there's no point in this, but I'm just doing that to like keep up a pattern that you're going to see in a minute. So do jump if not equals to R6 and make to 0. Yeah. Invalid. system program ID. Yeah, so the reason I'm putting 0 here is that most people should be familiar that, okay, most people are going to be familiar with this is how the system program is. But this is just the base 58 encoding of what the system program is. The system program is actually 32 zeros. It's just, I can't type, I'm not typing 32 zeros. But yeah, the system program is just 32 zero. And the ones you usually see are just all the basic 58 encoding of it. So the reason why this is valid is that we're just checking that, okay, R6, our system program, the first 8 bytes of it, the first 8 bytes of it is equals to 0. So that is why we can set it that, oh, let it R6 be equals to 0. That's the first 8 byte of the system program key. So if it's not equals to 0 as usual, we're going to like tell it to go to a set. So if an attacker knows that, okay, we're only checking for the first 8 bytes, they could just like, okay, create a vanity type of address that, okay, only the first 8 bytes is 0 and the rest is just like something else that they could make a fraud. So to be on the safe side, we're going to now validate the entire 32 bytes. So this validates the first 8. This is going to validate the second 8. This is going to validate the third 8, and this is going to validate the fourth. Since, okay, although just because of registers are 64 bits in nature, and that's just 8 bytes, and they can't contain the full 32 bytes of program ID, we're just going to verify it in chunks. So that's all this is. So if I did not mess it up, if you run it right now, the program is supposed to work. Oh, and look, it works. So do I say, oh, that I'm surprised that my own code works? But yeah, sometimes you make mistakes. So let's say fake. If we just replace that over here and say .pop key, it should fail. And look, it does fail and it gives us that setting error. So yeah, in this video, we've managed to like do a couple of checks, like see a simple rundown of how we do some like common account checks with assembly. It does get more complicated than this, but I just like do these simple checks to just give us like a quick vibe of it, and to show you that, oh, it's not as complex. Although there are a lot more things to consider, it's not as complex. And yeah, that's pretty much it for this video. See you for the next one. Bye.